If we have established already systems are governed by their constraints, the first thing we must do is to find it. What's yours? Do you know? Is it where it is because you've designed your value creation engine to take advantage of the laws of physics? Or are you forever its victim, watching it turn up unannounced in a different place every day, like whack-a-mole? Once we've found what our constraint is, then if we want to optimize value creation, we must optimize its performance. How would you go about doing that? To change up performance at the constraint, do you agree we need everyone else in the engine room to collaborate around that proposition? That is, the proposition that in the same way the orchestra supports the soloist, the non-constraints support the bottleneck to optimize bottleneck performance. How do you methodically go about creating such collaboration? Not only technically, but also behaviorally. There comes a point where you hit the law of diminishing returns on optimization, and it's time for investment in new capacity, what we call uplift. How do you determine when it's time for new investment? How do you know when you've maxed out your existing engine? How do you know what to invest in next? Our experience tells us you usually have at least 25% more capacity than you think reasonable and possible in your existing engine. It is such a common error to invest too early, too late, or in the wrong things because you're so busy managing the parts, you lose sight of systems view of your value creation engine. It follows then that once you have made the investment to uplift current constraint capacity, you'd be well advised to start this 5-step focus again, as the constraint will have moved. Where will it go? Supply? Make? The marketplace? The answer to these questions will be fateful and have strategic consequence. As part of the science of work component of the Ensemble way sits the TOC approach to managing systems, such as the one we've been looking at. It's called Drum Buffer Rope, or DBR. Let's take a closer look at how Dr. Ellie Goldratt, the physicist founder of the method, came up with such a name. The constraint in our example is the salesperson who can only cover off 10 sales per day. We call this bottleneck resource the drum because it beats the rhythm of value creation. The power of this idea resides in the fact that a 10% gain at the drum is a 10% gain for the system as a whole. 10% more capacity for the salesman means 10% more sales for the whole enterprise. And in most cases, the value of that gain in throughput dwarfs whatever happens to operating expense. And the great thing about designing where you want your drum to be is that you can use it to synchronize the whole engine to this drum beat. Everyone marches to the same drum beat. And because by definition everyone has more capacity than the drum, 10% gained at the drum is 10% gain for the system as a whole. But everyone has to play as one band. If the drum is starved because the upstream process was goofing off or produced the wrong component, the whole system loses out. So how do we ensure that the drum never runs out of work? Well, we place a buffer in front of the drum. This buffer is in effect the stored capacity of the upstream functions. We want to size the buffer so it's not too big to flood the engine with work in progress. But nor do we want it to be so small that the drum misses a beat because it's starved. To keep the size of the buffer right, we tie a rope to the release of inputs at the entry point to our engine. The buffer is sized to be big enough to accommodate the time it takes from the input step until it's ready to be processed by the drum. As soon as the drum has begun work on the buffer, it gives a tug on the rope to release the next work pack so it arrives in good time to keep the whole value creation engine running smoothly. With our drum buffer rope system in place, we pretty quickly end up with a 10 out of 10 performance. So it's time for a change up, the uplift step. There's no way to get extra capacity out of the system in its current configuration. What we need to do is to make an investment in additional resource. Adding another unit of the drum takes the combined uplifted capacity to 20 units, which is more than the market demands. So we start again with our new drum. And notice that our value creation engine is producing more than the market will absorb. The constraint has moved into the marketplace. The internal constraint has become external. It's time to find new markets for existing products and services, or new products and services for existing markets, or some combination of both of them.